It's a rational function. It's got x's on the top and x's on the bottom. We noticed that the numerator is quadratic. So hopefully you're able to easily identify that. If not, remember that you're looking at the largest exponent on x. In this case, the largest exponent on x is 2, and that means it's quadratic. So when we care about horizontal asymptotes versus slant asymptotes or oblique asymptotes, care about the degree of the numerator. The degree of the numerator is 2, and the degree of the denominator is 1, because there's an implied 1 right here. And 2 is bigger than 1, and so that tells me that I'm going to have a slant asymptote. And of course, that's the feature that's different to this problem versus the other problems that you've been doing. So that's the feature I want to focus in on. So what we're going to do is we're going to take the numerator and we're going to divide it by the denominator, and this part here is going to give us our slant asymptote. So that's summary. So let me just go ahead and go through that. So I have negative x squared minus 4x plus 1. Since this is an x plus 3, I really could use synthetic division if I wanted to. Might be quicker. I'll go ahead and do it the long way. So we look at negative x squared divided by x. Negative x squared divided by x gives me negative x. And so then I multiply. So I am taking the x plus 3 and multiplying it by the negative x, and I get negative x squared minus 3x. But I'm subtracting that. So I can do that off on the side. I got negative x squared minus 4x. I'm subtracting negative x squared minus 3x. These signs are really where it's easy to make mistakes. Negative x squared minus 4x. That's going to be plus x squared and plus 3x. And these cancel, and I'm left with negative x. Gotta get negative x here. My check step, so I know that with division, my process is divide. That was figuring out what the negative x was. This was multiplying. Subtracting, which I did, and then checking. That's making sure this term has disappeared, and then bring down. So I'll go ahead and bring down the 1. And so I'll repeat the process. So I'm back to divide. So negative x divided by x. Answer is negative 1. So this is minus 1. So now I'm at the multiplication step. So I take negative 1 times x, negative 1 times 3, negative 3, and then I subtract it. So negative x minus negative x will become negative x plus x, which is 0. 1 minus negative 3 becomes 1 plus 3. So let me show you a little bit of extra stuff that you don't need to do in case you care. So I know that negative x squared minus 4x plus 1 divided by x plus 3. The answer to that division problem is negative x minus 1 plus 4 divided by x plus 3. Okay. But slant asymptotes or oblique asymptotes tell about end behavior. And so if I look at this last term, if I use x equals 10 or 100 or 1,000, or if I use x equals negative 10, negative 100, negative 1,000, if you just plug those numbers in, okay, you'll see, you could go further, you'll see that 4 over x plus 3 the answers to that, as you continue in one of those directions, are going to go to 0. Okay, so this term does not contribute much. It does not count much towards end behavior. So we're going to throw that away, and we're only going to look at the quotient. We're going to use y equals negative x minus 1 for our slant asymptote. And so what else do we know? So we should talk about, well, there's no horizontal asymptote because the degree of the numerator is bigger. We have slant asymptote instead. We could ask about vertical asymptote. Remember that is the denominator. So x plus 3 equals 0 gives us x equals negative 3. I could also figure out x-intercept. For the x-intercept, I take this big thing and set it equal to 0. By doing some stuff in my head, I can see that there aren't any nice answers. Those answers will actually be irrational or non-real. And the problem probably does not ask me to give those. Sometimes it asks for the intercept, sometimes it doesn't. The y-intercept is really easy. Might as well do that. Y-intercept, if I plug 0 in, I get 0 minus 0 plus 1 over 0 plus 3. So I know the y-intercept is 1/3. So I know that I have slant asymptote of negative x minus 1. So negative 1 tells me that the y-intercept is negative 1, and that's the first thing I do. So I plot the y-intercept. And then the second thing I do is my slope is negative 1. So I'm going to think of that as maybe negative 1 over positive 1. I could do it switch the signs around. So this tells me my change in y is negative and my change in x is positive. So I go down 1 and right 1. Now I know that if my slope is negative, my line should be decreasing as I go from left to right. So this is actually my slant asymptote. Remember, slant asymptotes and horizontal asymptotes don't tell me about the middle of the graph as much as they tell me about the end of the graph. I also have the vertical asymptote at negative 3. So negative 3 is over here somewhere. And so what we'll do for our table of values is we are only going to worry about the vertical asymptote. So let's see, 2 x's and then 2 x's to the right. So this x right here will be my vertical asymptote. So my vertical asymptote was at negative 3. So let's go ahead and do negative 4, negative 5. And then negative 2 and negative 1. And so you plug those in and you plot those points. So it looks like I have 1 over negative 1, which is negative 1, 5 over 1. And so I know that this point, negative 4, negative 1, is that right? So I'm guessing that this graph is going to kind of go like this then. It's got to bend towards these 2 asymptotes. And then if I look at where negative 2, 5 is, that's up here. And so it looks like it's probably going to fill this corner. You just plot your points and let Alex do the rest of that.